So today we're going to be working on 3.3, which is one-to-one functions and their inverses. So we've got two learning targets: determine if a function is one-to-one, and then find the inverse of a function. So if you remember, to even determine if something's a function to begin with, we use what's called the vertical line test. If it passes the vertical line test, as you take a vertical line and you go through your graph, it only passes in one point. It passes the vertical line test, and therefore it's a function. And basically the x's do not repeat. Well, to be a one-to-one function, it's already passed the vertical line test, but we're going to use the horizontal line test to see if it is a one-to-one function. And basically that also tells us that the y's do not repeat in that. So I can go ahead now and look at the first example there. I've got these ordered pairs 4, 10, 3, 7, 2, 4, 1, 2. Notice the y values do not repeat. You've got a 10 there. We've got 10 for our y, we've got 7 for our y, we've got 4 for our y, and we've got 2 for our y. The y's are not repeating, therefore it's one-to-one. Then the second example there, notice you've got 10 for a y, 4 for a y, 4 for a y, and 2. You have these two ordered pairs over here where the y's do repeat over here. You've got a 3, 4 and a 2, 4. So that one is not one-to-one. So now, if you're given a graph here, you can definitely just use the horizontal line test there to figure out if something's one-to-one. So if I were to take a horizontal line here and just draw it through my graph there, you can see it definitely passes there in 2 points. You've got a point there and a point there. So definitely no, this is not a one-to-one function there because it fails the horizontal line test. It can only go through, as I take a horizontal line, I go through my graph, it can only pass there in 1 point. So in this one over here in letter B there, is this function 1, 1? Well, yeah, as I take a horizontal lines and I go through there, it's only passing through 1 point at any given time. So yes, that one there would be considered one-to-one. Well, what happens if we do not have a graph? Well, we've got an equation instead, so we could just very easily take out our graphing calculator and graph it into our graphing calculator. So for instance here, I can take x, caret key, 3, let me move this. Sorry about that, it's kind of whipping around there a little bit. There, we'll move it up there, you can see it better. Alright, so x to the third, and then minus 1. I'm going to go ahead and graph that out there. And again, you're going to use the horizontal line test. Is that a graph? Is that a one-to-one function? Well, yeah, as I take a horizontal line and I go through that graph, it is only going to pass in one given point at any time. So definitely a one-to-one function. So that first one there, we can go ahead and say that yes, it's one-to-one. And then we can check our other one there. So let's do that. So I can go to my y equals here. I'm going to clear that out of there. I'm going to hit x squared plus 3. Hit graph. Now use a horizontal line, and if you go from the vertex on straight up, it's going to definitely pass through 2 points. So that one there is considered not one-to-one. So we're going to say no, or just not one-to-one. All right. Now we're going to look at the second part here. We're looking at inverses. So we're going to kind of look at inverse functions and the original function there. So if you look at the domain of f of x, it's considered, if f of x is 1-to-1 and has a domain of a and a range of b, then the inverse function has a domain of b and a range of a. So you can see that the domain and range have been swapped. So in other words, if in one of the functions, and it doesn't matter which one, if you have an ordered pair of xy, then its inverse, or vice versa, if the first one is the inverse, then the original function, you just reverse those values. So in other words, if this one is 7, 3, then the inverse functions is 3, 7. So that's the relationship there when they're inverse functions, is that the x and the y is their switch. So let's assume that f here is 1 to 1. You've got these nice ordered pairs here. We have the ordered pair there of 1, 5. And we have the ordered pair there of 3, 7 for f. And we've got the ordered pair there of 8, negative 10. All right. In the inverse function over here, they're saying, okay, what happens if the x value here is 7? We want to know what the y value is. And then the inverse function there is x value is negative 10. What's the y value? Well, we've got a relationship going on here. So looking at my relationship here, I can see that this one here has a 7. It's 3, 7. So remember, they're swapped. So this one's 3, 7. Its inverse then is 7, 3. So this here has a value of 3. And then I can look at the same one. Well, I'm looking at negative 10 something, so come over here and look at the y value. Because remember, they're swapped. If this is xy, if 8 there is x, and y is negative 10, then its inverse function is negative 10, 8. You switch the x's and the y's. So what's this value over here? The inverse of f there at negative 10 is 8. All right, so now let's come down here and look at this other one here. So this one here says we've got an ordered pair here of 3, 8. That means that the inverse function just swaps, becomes 8, 3. So remember, this is saying here, if this is your x value is at 8, what's its y value? 3. Right? And then it doesn't matter, now you've got the inverse notation here. This is saying that the x value is negative 3 and its y value is negative 1. We swap them going the other way as well. So now you got negative 1 and its y value there should be negative 3. So what's f of negative 1? It has to be negative 3. Again, you just swap the x's and the y's. You just switch them. So now sometimes they also give us a function here, so they don't give us the entire ordered pair, but we can find the ordered pairs. But let's kind of think through what this is actually asking us. So this one over here, the inverse, they gave us 7, and we're supposed to find the y value to go with it. They gave us 10, and we're supposed to find the y value to go with it, which means in the original function, we don't know what the x value is, but we know the y value is 7. In the original function, we don't know what the x value is, but we know the y value is 10, because remember, this is xy. If this is xy, then I got to switch it, and it's got to go the other way. Right? You just swap them. So in other words, up in here, if I've got the nice function for f here, I can just plug in 7 for my f of x or my y value, and I can solve for its x value. So if I put in 7, I can add 1 to both sides. I can divide by 2, and x just ends up being there 4. So my ordered pair there is 4, 7, which means over here it becomes 7, 4, which means this answer here is just 4. So now let's do the other one. So kind of working through this. Now my value down here is 10. I'm going to plug that in for my y. So 10 equals 2x minus 1. I can add 1 to both sides. I get 11 equals 2x. Divide by 2, and x is 11 halves. Or, if I want a decimal, 5.5. So coming over here, I can write in 5.5. So that means over here, this is 10, 5.5. So what is the inverse of f at 10 there? It'd be 5.5. All right, so now let's come down here and let's do it again. Let's do some more practice on this. So again, we have 3 comma something, which means over here we're going to swap them, becomes something comma 3 in the original function. In the inverse we have 0 comma something, so then in the original one it's something comma 0. So plug them in there. So I'm going to plug them into my function there. I'm going to do 3 equals 2 minus x. I can subtract 2 from both sides. I get 1 equals negative x. Divide by negative 1, and x equals negative 1. Oops. I just started writing all over the place. So now, see if I can erase some of that. Alright, so I'm just going to clean this up a little bit. And this down here is actually going to give us our value of negative 1. Alright, so now we can do our other one here as well. So let's just go back up here before. Let's put this in here for this is negative 1 then. So that means this over here is negative 1. So when they're asking what this value here is, it's going to give us a negative 1. So now I got to work with the 0 one. So I'm going to plug 0 up here in for the f of x. So it becomes 0 equals 2 minus x. Subtract 2, I get negative 2 equals negative x. Divide by negative 1, and I get x equals 2. Which means this is 2, 0, so this is 0, 2. So what's this value right there? It has to be 2. Alright, so let's also look here at some values here. We've got to find the inverse. We're going to do some graphing here, so let's do some graphing on this. So graphing this out here, I've got 2, 1, and I've got 5, 1.